In this video, I'm going to discuss Saccheri's construction as well as prove Saccheri's theorem. For Saccheri's construction, we need to start with a right triangle. So I'm going to go ahead and draw that. Here's our right angle at C. And then we have points A and B. And the only condition here is our sides need to have length less than alpha over 2. The next thing we're going to do is find M to be the midpoint of side BC. So we'll let M be the midpoint. And N will be the midpoint of side AC. So the fact that these are midpoints tells me that all of these sides are congruent. And then I'm going to draw the line MN. So we want not just the segment, but the full line through these points. From there, I want to draw perpendiculars from A to this line and from B to this line. So we'll draw these perpendiculars up. There's the one from A and the one from B. We'll call these points A prime and B prime, and they were done so that these angles right here are right angles. I'm also going to do the same thing for C. We'll draw that point down and get C prime right here, once again as a right angle. So I now have a quadrilateral with one side that is the length of the hypotenuse of this triangle. So now that we have the construction, we can discuss Saccheri's theorem. Saccheri's theorem says that this quadrilateral A prime B prime BA is a Saccheri quadrilateral. It has base A prime B prime and summit AB. Moreover, it also tells us that the angle sum of triangle ABC is twice the measure of each summit angle. So if I add up the angles of this triangle, it is 2 times one of these summit angles. So we're going to go ahead and try to prove this. For a Saccheri quadrilateral, we need right angles, which we do have, and then we need the sides to be the same or the angles to be the same to prove that this is a Saccheri quadrilateral. In order to prove this, I went ahead and moved a smaller version of my picture down here so that we can reference it. We have that angle CN C prime is congruent to AN A prime by vertical angles. We also know that A prime N is congruent to C prime N since they're both right angles. And in addition, AN is congruent to NC by the way we constructed this point N. This tells me that by angle side, we have that triangle A prime NA has to be congruent to triangle C prime NC. So these two triangles here are congruent. Well, that tells me that AA prime has to be congruent to CC prime. Similarly, we can get that triangle B prime MB is congruent to triangle C prime MC. And once again, we have that CC prime will need to be congruent to BB prime. Well, this tells me that AA prime is congruent to B prime, so I have that these sides here are congruent, which gives me that this is a Saccheri quadrilateral. To get the angle sum piece of this, I went ahead and labeled some angles. The angle sum of our triangle ABC is the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 6. This is the same thing as the measure of angle 1 plus the measure of angle 2 plus the measure of angle 5 plus the measure of angle 6. So by the fact that these triangles were congruent, I have that angle 3 and angle 2 are congruent and angle 4 and angle 5 were congruent, which is what gives me this here. Well, the measure of angle 1 plus the measure of angle 2, this is the measure of angle A prime, AB, plus the measure of angle 5 plus 6, which is B prime, BA. So we have that the angle sum is the sum of the two summit angles, which would give me exactly what I need. That if I have one of them, doubling it gives me the angle sum. So I have proven this.